Let us see, children, question number 13 of 6.2, that is applications of derivative. You are watching Shakya Academy, whose phone number is 941925461. Today we will discuss question number 13 of this exercise 6.2. Question says, on which of the following intervals is the function f given by f of x raised to 100 plus sin x minus 1 is decreasing? So we have to find out of these four options which option is correct for the function, given function is decreasing. Okay, so we'll try first. So we'll write a function fx is equal to x 100 plus sin x minus 1. So to know increasing or decreasing, we have to get its derivative. F dash of x is equal to 100x raised to power 99 plus cos x minus 0. So this will be 100x 99 plus cos x. So for first option A, we'll put this interval. So we can draw the table here. Very simple. The table will be like this, and we'll have the line is this. This is 0, this is 1. In between these two, let us say 1 by 2. So when we'll place 1 by 2, this will be, here it is interval we can write, and here it will be f dash x is equal to 100x 99 plus cos x. Here the nature of function, increasing or decreasing. So we'll put here the interval is 0, 1, and we'll put here 1 by 2 f dash x. In place of x we'll put 1 by 2. So this will be like this, 99 plus cos 1. So these two values will be positive. This will be positive. So the function will be increasing. Okay. So this option is not acceptable. Now let us try B. B says, for B the table will be like this. For B the table will be like this. Our interval, then f dash x and the nature. Interval, then f dash x is equal to 100x 99 plus cos x, and here we will write nature. Okay. So our interval is pi by 2 pi. So we'll draw a line here. This is pi by 2 and pi. So this is second quadrant. Okay, second quadrant may, you will find that this will be, if you put any value here, this will be positive, and this will be a little value for any value. So let us say pi by, this is 90 and this is 180. So here we can say 3 pi by 2. Okay, 3 pi by 2. So this will be equal to 270. This will be wrong. This will be wrong. This will be wrong. This will be wrong. So we can take here. Between 90 and 180 degree. So we can take 120 degree. Okay, and 120 will be 180 minus something by 2, and this will be equal to 90 minus something is equal to 120. So this will be equal to 120 by 90, and this will be this 4 by 3. Okay, so this will be 4 by 3. This will be 4 by 3. So this will give us again the positive value. Here it may be negative, but this will be far. We can say 100 x 99 is much greater than cos say 120 degree. Okay, 120 degree. So this will be though negative, but this will be very small value. So we can say this gives us a positive, that is f dash x is greater than 0 and the function is increasing. Function is increasing. Now let us try C. C says, let us draw the table like this, and here we will have interval and then f dash x. So interval is 0 comma pi by 2. This is first quadrant. Okay, so in the first quadrant cos x will be positive and f dash x is x 100 x 99 plus cos x. So this will be positive, this will give us positive. So the function will be increasing. Okay, so none of these A, B and C has given us value for decreasing function. So option D is correct. Okay, option D is correct option. Now let us try next question, question number 14. And question number 14 says, prove that the function f given by fx log sin x is increasing on this and decreasing on this. So we have been given two intervals, 0 comma pi by 2 and pi by 2 comma pi. This is first quadrant and this is second quadrant. We have to prove that log sin x is increasing on this interval and the function is decreasing on this interval. So let us write first f of x. This is given log sin x and its derivative will be 1 upon sin x and cos x. So this will be tan x, sorry, cot x. This will be cot x. This will be cot x. This will be cot x. So in the interval 0 comma pi by 2, that is first quadrant, cot x will be positive. So the function is increasing. First part is proved. This is true. Now let us say second part. Second part says in the interval pi by 2 comma pi. So this is second quadrant. In the second quadrant we can write in the second quadrant cot x will be negative. Therefore cot x is less than 0. So the function is decreasing. In pi by 2 comma pi interval. Hence proved. Hence both the parts are proved. Now let us see question number 17, which says prove that function f given by f of x is equal to log cos x is decreasing in the interval 0 comma pi by 2 and increasing on 3 pi by 2 comma 2 pi. So let us write the function first. F of x, this is equal to log cos x. F dash x will be minus 1 upon cos x and into 1 upon cos x into minus sin x. Okay, so this will be plus tan x. This will be plus tan x. So in the first quadrant In the first quadrant, this will be minus 10x. So in the first quadrant, tan x will be positive. Tan x is positive. Tan x is positive. Therefore, f dash x will be this negative and this positive. So overall it will be negative. And when it is overall negative, the function is, therefore the function is decreasing. The function is decreasing. So first part is proved. Now for the second part, where the interval is given, here this interval was 0, pi by 2. And for the next interval, 3 pi by 2, 2 pi, 3 pi by 2, 2 pi. This is fourth quadrant. This is fourth quadrant. In the fourth quadrant, tan x will be negative. Okay. So this will be minus and minus for tan x. This is for tan x. So this will give us positive, and so the function is increasing. So the function is increasing. This is question number 17. Now let us see question number 18. We have to prove that in real domain the function is increasing. So let us write first the function. The function is x cube minus 3x square, x cube minus 3x square plus 3x minus 100. Its derivative will be 3x square minus 6x plus 3. We can take 3 as common from each term of the function. I mean the derivative. This will be x square minus 2x plus 1. And this will give us x minus 1 whole square. Let us put f dash x is equal to 0. So 3x minus 1 square is equal to 0. So value of x will be 1. Value of x will be 1. Okay. So this is greater than 1. This is greater than 0. This is greater than 0. So f dash x is greater than 0. That is positive. This is positive. So the function will be increasing. So the function will be increasing. So the function will be increasing in R. For any real value, it will give us positive value. Okay. So we can try this. This will be always positive. Now, so hence proved. Now question number 19, which is the last question of this exercise, which is the interval in which y is equal to x square e raised to power minus x is increasing in this interval or this interval or this interval. So we have to choose the correct interval. We have to select the correct interval. So we'll try all the intervals. First of all, we'll write the function, and the function is x square e minus x. Now we'll find out its first derivative, that is f dash of x, and this will give us the product rule. By product rule, we'll write x square d upon dx e raised to minus x plus e raised to minus x d upon dx x square. This is by product rule. This is by product rule. Product rule is, the formula says, let us write the product rule. The product rule is, if there are two functions u and v, so d upon dx u v with respect to x will be first derivative we can write as such, and the second derivative, first function can be written like this u, and this will be v. Then second function will be written alternately. You have to differentiate both the functions with this plus sign in between. So when we'll see this will be x square, and the value of this will be minus 1 for this minus 1, and again we'll write this is minus 1 and e minus x. Okay, e minus x. So this will be minus x square e raised to power minus x. So this will give us negative value. This will give us negative value. Therefore, this will be decreasing. So option 1 is wrong. Okay, this is option 1. For any value between minus infinity to plus infinity, we will get negative value of the function. So this will be decreasing. This is for option A. Option B. Option B says x will be minus 2. So this will be minus and minus 2 square. Clear? And e minus minus 2. So this will be minus 4 e raised to power plus 2. So this will also be negative value, and for negative value the function will be decreasing. So option 2 is also wrong. Option B is also wrong. Let us try option C, which will be to infinity. So we'll write any value here, minus 2 minus 2 here square and e minus 2. So this will give us negative value. It is again decreasing. Now let us try the last option. It is often the last key of the bunch which opens the lock. So let us try this section also. I mean this option also. So we'll put in place of x between these two, we can put 1. We can put 1. So when we will put 1, when we will put 1, and this is also given here, no? E minus x 2x. Okay. This is wrong. This is wrong. This is wrong.